1.5 and 1.6. This is going to introduce us into angles. So in 1.1 we talked about points, lines, and planes. Now we're going to see what happens when we add them together. So when we have points and lines and rays, we're not going to talk about planes just yet, but these line segments that can be put together can be called angles. And you can see that there's a space in between them, and we measure how many degrees that space covers. So over here, first off, let's talk about the vocab a little bit. So whenever we're talking about an angle is a set of points consisting of two different rays that have the same endpoint. So we're talking about rays. AC is a line segment, but AC could also be a ray in the fact that AC keeps going on forever. So if it stops, we're talking about the segment. If it keeps going, we're talking about the ray. And this space in between is where angle 1 is. The vertex is the point where those rays meet, or where they originate. So this point right here at the very tip is called the vertex, and that's a very important word to know. So make sure that you've got that one. The rays are the sides of the angle. The interior of an angle, this is the interior of the angle, and you can see it down here. Here's the interior of the angle. Here's the exterior of the angle. Now, if you add the two, this isn't part of this section, but if you add the interior and the exterior, you will always get a circle. Now, how many degrees is a circle? Well, a circle is 360 degrees, right? So if you add up the interior and the exterior, it will always be 360 degrees. So you can go through a couple of the others of these. Measure of an angle, let's go ahead and look at that. Zoom it back out. It says measure of an angle is on page 37. Let's go take a look. So this is called a protractor. You won't need one for this class, but you need to know how they work. I'm not going to make you measure angles, but I will make you find the measure of angles, and we're going to talk about that here in a minute. So the measure of AOB. In order to talk about how big this is, I want to first talk about different kinds of angles. So I'm going to actually jump down here. An acute angle, you can think of it as something that's like, oh, that's so cute, it's so small. An acute angle is small, measures greater than 0 and less than 90. Because if it is 90, that's called a right angle, and you'll see this special square, or you can draw that special square to show that it's exactly 90 degrees. An obtuse angle, obtuse is big, and so that's going to be bigger than 90, but less than 180, because if it gets to 180, we call that a straight angle. So many of you already knew what a right angle was. That's 90 degrees. There's another special name if it's straight 180 degrees. That is called a straight angle. You can picture me holding my arms, and you can do this at home. Hold your arms straight out. You've made a straight angle because your arms are straight out, right? Make a right angle. That looks kind of like a cheerleader pose, right? If you were in class, you would see me doing all kinds of cheerleader poses for when we're talking about angles, because that's a thing. So acute angles, it's so cute, it's small. Right angle, it's exactly 90 degrees. Obtuse is big. Technically, obtuse means thick, but this is pretty thick. Straight angle is just straight up 180 degrees. So those are all angle measures. So when we look at AOB, classifying these, AOB is an obtuse angle because it's bigger than 180 degrees. So when you're using a protractor, you've got two different sets of numbers. Take a look, 0, 10, 20, 30, 40, but it also says 180, 70, 60, 150. So a protractor measures two different sets of angles. It gives you an angle measure for if it's acute, if it's less than 90, and it gives you the angle measure for if it's obtuse, for if it's greater than 90. So we know that since AOB is an obtuse angle, it's bigger than 90, right? Because it's bigger than that straight up and straight over, that it's going to be obtuse. So am I going to use the 40 or the 140? Well, if it's obtuse, it has to be greater than 100, or it has to be greater than 90 degrees. And so we're going to use that 140. Does that make sense? That's how you measure an angle. That is the measure of the angle. Okay, so that is how you use a protractor. So let's do a couple of examples here real quick. If I want to measure JHK, okay, so this is something that's really important to notice. All angles are either going to be identified by a number, like what happened over here, where this is called angle 1, or it's going to be identified by 3 points. So J to H to K. I want you to follow it with your finger every time you're going to be measuring an angle or following an angle, because that way you can actually visualize what letters it's using. So it wants GHK first. So let's go G to H to K. Well, is GHK bigger or less than 90? Is it acute or is it obtuse? So we know that it's obtuse because here's my 90 degrees and it keeps going past that 90 degrees. So which number are we going to use? Well, we're going to use the number that's bigger than 90 because the angle is bigger than 90, right? Now it's right there in between the 120 and the 130, so this is going to be 125 degrees. So that's kind of how you do these. Let's go ahead and zoom back out. Let's talk about, we already talked about acute, right, obtuse, and straight angles. Let's talk about congruent angles. We've talked about congruent before. Think about it. What does congruent mean again? Equal means they have an equal value, right? They have the same value. But congruent means they're the same in size and shape. So that's really important. It says that talking about congruent angles is on page 38, so let's zoom out and go to page 38. Two angles are congruent angles when they have the same measure because they're always the same shape. They always have that angle measure. It matters the angle size, right? So if the measure, and that's what this M means, if the measure of angle A is equal to the measure of angle D, the M stands for measure, then angle A is congruent to angle D. Now this equal sign with the squiggly is really super duper important. So if you didn't catch that from previous sections, now is the time. If the measure is equal to the other measure, if the numbers are the same, then angle A is congruent to, is the same as angle D. If the measure is equal to the measure of angle D, then angle A is congruent to angle D. Got it? Okay. I think there was one more vocab word. Angle bisector. Now this is really important. We talked about segment bisectors, but only a little bit. A segment bisector cuts a segment exactly in half. Bisect means exactly in half. So an angle bisector, if you've got X, Y, Z as one angle, the angle bisector cuts it exactly in half. Now this green mark and this green mark means that this one is the same as this one. That's a congruency mark. So that's really important to note. And that's 1.5. So let's go ahead and go to 1.6 really quick, talk about that. Describing pairs of angles. So this is all about special angle pairs. Complementary angles, supplementary angles, adjacent, linear, and vertical angles. So, complementary angles, and this is going to take more than one view to really get these down. So don't feel bad if you need to come for more information or if you need to watch this video 2 or 3 times. Complementary angles add up to be 90 degrees. So angle A and angle B here are complementary because this one's 20, this one's 70. If you add them both together, you get that right angle, right? That angle right here, and you can see the right angle. The two angles with their measures added together equals 90 exactly. Now, so that's complementary angles. Supplementary angles, you add the angles together to get a straight angle. So angle 3 plus angle 4 is that straight angle. Do you remember how many degrees a straight angle is? Spoiler alert, it's already in here. It's 180 degrees. So a right angle is 90 degrees. That's complementary when the two add together to be 90. Supplementary, they add together to equal 180. So this 115, angle C, and angle D right here, those two add together to be 180. So those are supplementary angles. One way to keep them straight is that complementary comes before supplementary in the alphabet, C comes before S, and 90 comes before 180. There are lots of different ways to think about this. I'm going to try and add another YouTube video or two from other people who may explain it in a way that you understand better. Adjacent angles. If I live in an apartment building and I want to talk about my adjacent neighbor, the person adjacent to me is right next to me. So sometimes in an apartment you have 3 or 4 adjacent neighbors, right? Depending on what floor you're on and where you are in the floor plan. So adjacent angles always have this common side, something that they share. If you're living in an apartment, or even if you're living in a house, like right next to us, and your room is right next to your sibling's room, if you hit the wall, thump, and your sibling can hear it on the other side because you have that shared wall, that is your common side. Or if you have somebody living below you and you decide to river dance and stomp dance on your floor, that is a common side because your floor is their ceiling. So you are adjacent neighbors. Adjacent just means right next to each other. They have that common vertex. They have that common wall, that common side. 7 and 8 are not adjacent. They are non-adjacent angles because they're not touching, right? They have space in between them. So this would be like one apartment building, and this would be another one, a really small apartment building, right? An acute apartment building. Okay, so identifying pairs of angles. You can go through these examples in your book, but CAB is adjacent to CAD because they have that shared side of AC, that ray AC. So they're adjacent to each other, but you'll notice they're not supplementary because they don't add up to be 180 degrees. That's also not complementary because they don't add up to be 90 degrees, right? So these are not supplementary, they are not complementary, but they are adjacent. Okay, let's see what else we've got. The linear pair. Linear pair, it says, is on page 48. Let's go ahead and go to page 48. Doing these examples in the book, by the way, following along with those will really help. Okay, and I'll talk about this more next week. This is kind of an introduction into what we're going to be doing next week, but this is absolutely critical because if you understand these, you will do well throughout the entire semester and the entire year. And if you never understand these, you are always going to struggle. So if you don't understand these, even after next week, please let's get together and have a tutoring session, but please also make sure that you're utilizing the resources that you have available, the YouTube videos, the links, the assignments, the textbook, all that jazz. Okay, sorry, I digress. Linear pairs and vertical angles. Linear, see how it has the word line in there? Linear pair is when two angles have that common side. They are adjacent, but it's a special kind of adjacent pair. This adjacent pair makes a straight line. Notice if we do it right here, and we're just measuring angle 4, that's not a straight line, is it? It stops at the vertex and then it keeps going. A linear pair makes a straight line. This says their non-common sides are opposite rays. So if I had a little dot here, one ray would go this way and one ray would go exactly the opposite way. But I just like to keep it simple. A linear pair combines to make a straight line. They are adjacent, they're right next to each other, and they make that straight line, that 180-degree angle. And that's really important to know is that this angle 1 plus angle 2 is always 180 degrees. Vertical angles, so I want you to make an X with your arms And move your arms back and forth and notice what happens to the size of the angles opposite each other. Okay, now take a look here. Angle 3 and angle 6 are connected in the fact that they will always be the same size. 3 is always the same as 6. 4 is always the same as 5. Now, cross your arms together again and try and notice that relationship, that as you make one angle smaller, the angle on the other side gets smaller. As you make one angle bigger, the other angle gets bigger. This is just something that happens, right, with straight lines. So that's what vertical angles are. Vertical angles says, if I know angle 3, I automatically know angle 6. If I know angle 4, I automatically know angle 5. And these are all going to be really super duper important. So again, we'll get into this more next week. If you're looking at this video next week, then that's what we're doing this week, right? Make sure you're really familiar with angle measures and these special angle pairs. Okay, again, that's going to be in chapter 1. We're in 1.5 and 1.6, and that's going to end the chapter.